Before we move further to solve problems, here are some conceptual questions about spring force. Let's go through these few. How might the shape of an object change if the forces act away from each other in a straight line, which means you have an object, you have two forces and pulling it away from pull away from each other. And based on your intuition, it compresses. And so now the second question. How might shape of the object change if the forces act towards each other in a straight line? Basically, you squeeze it and it will shrink. So it might compress, depending on how hard it is, but it always compresses a little bit. Okay, and now, which statement best describes Hooke's law? Hooke's law says basically the force is proportional to the extension, which means stretches, and the restoring force is in the opposite direction of the extension, and therefore there is a minus sign. So force equal to a constant, which is called K, times the extension, which we sometimes call delta x. If you put a weight at the spring, that's the displacement of the spring, assuming that x direction is the positive direction. The Hooke's law is only describe the linear part. Of course, anything, if you stretch too much or compress too much, it will not follow the Hooke's law. So there's a limit. So then that's the ideal case. So then, of course, it's not. First one, extension of the spring is directly proportional to the force applied. That's only at the beginning. Oh, there's a limit. So extension of spring directly proportional to the force applied, provided that the limit of a proportionality is not exceeded. And then the other question is, extension of spring is inversely proportional to the force applied, provided that the limit of a proportionality is not exceeded. So that's directly proportional with this one. So, and this question, next question. What is the shape of the force extension graph for the spring if it obeys Hooke's law? So if I draw a picture, okay, and if I have, so force versus extension. So force on the top, okay, extension on the bottom. Extension, which means stretches, extension, okay, and then of course, is stronger you stretch, is stronger the force. Basically, it's an increasing function. The question is whether it's linear or not. It's straight. Yeah, Hooke's law says it's supposed to be straight, but it's straight. But if it's not straight, it's not Hooke's law. Could be this, like a dough, and if you stretch, but then of course it sort of like there's no more force. Okay, and then or if it's like a kind of a piece of steel or very hard, and you stretch it, you might go that way. So then this section and this section is in a straight line. So it's a straight line, and that is actually follow the Hooke's law. So Hooke's law is the straight linear part. So straight line. Okay, actually straight line through origin. Straight line through origin. This one, and definitely upward curve. The upward curve will be something like a piece of steel, or then you stretch, and then it will be like that, going very strong force. Okay, and now next question. What is the units of, what is this spring constant measure of? What spring constant is that K in the constant? It's a measure of the stiffness of a spring. So it's a stiffness, how strong it is. And usually the units is force per length per units. So all right, so and that's exactly the next question. What is the units of the spring constant? It's Newton times meter, Newton times meter squared, and Newton per meter. So that's Newton per meter. So in other words, if you stretch it 1 Newton, stretch 1 meter, and then there will be a force proportional to the stretch and how much you measure that way. Of course, sometimes you use centimeters and they use small forces, but it's always force over length. All right, so these are the conceptual questions. Okay, and you can go ahead and solve the real problems with numbers combined with Newton's second law and third law, and so on. Thank you.